When a system or solution is said to be in equilibrium, it's referring to the fact that the reactants are simultaneously forming products as the products are forming reactants, and this happens at a constant rate. Now, equilibrium can be shifted towards the reactants or to the product when a stress is applied on the said system or solution. Now, this can either occur, the stresses we'll be looking at today is adding material, whether that's starting material or ending material, which would be either adding reactants or adding products, or when we affect the temperature of the system or solution. And so the stresses can either make the product, there to be too much product, and the system will need to balance itself out to be in equilibrium so that it can make the reactants. So because there's too much product, it'll have to make more reactants so that the two sides are balanced out. And or there could be too much reactants, and so the reactants will need to make product in a forward reaction, so the system will be balanced out. Now, one of the stresses we'll look at today is adding material. Now, in this case, I have the 3 different stages of the chromate equilibrium. And so this is just the chromate before we have added more reactant or we have added product. And we can see that that is a darker orange. Now, when we add sulfuric acid, that sulfuric acid, which this is the finishing look, it's a lighter orange. We'll compare that in a second. When we add sulfuric acid, which is a reactant, because there's too much reactant, the equilibrium will shift to the product. And we can see that comparison. We can see that this is a much darker orange and this is a lighter orange. Now, when we add sodium hydroxide, which is a product, we now have too much product, so the system will say, okay, well, we need to balance this stuff out, so I need to make more reactants. So now the equilibrium has shifted towards the reactants. And if we see here, we can see that our acid is our reactant and our base, which is a sodium hydroxide, is going to be our product. And we can see that shift. And we can demonstrate it here, where if we compare it to our initial without adding anything, the last result is much, much lighter, as sodium hydroxide and sulfuric acid are both colorless. And we can see there's slight difference in color, where this one's lighter and this one's darker. Now, for our second comparison, which is for temperature, we will see cobalt. We'll set up a hot water bath, and we can see our cobalt solution, and this is just nothing added into it. And when it's heated in a water bath, what happens is that the reactants, because heat is actually a product, as we can see right here, the heat in this solution is a product. So if we're heating the reaction, that means that we are adding product, we are adding heat. And so that means that the equilibrium will shift towards the reactants because there's too much product, because we've added heat into the system. And the original chemical equation is actually exothermic, because we release heat. But in this backward or inverse reaction that we see here, from the products turning to from the equilibrium shifting towards the reactants, the system now is endothermic, because we're using heat to create the reactants. And we can see that change in which this becomes much more darker. After it has been heated, it becomes much more darker. And that is how equilibrium is stressed and changed. That is how equilibrium is stressed and changed to shift from reactants to products, or from product to reactant.